Today, we're going to talk about webhooks, what problem they solve, and why they exist. To understand that, let's start with a simple real-world example. Imagine you're waiting for an incredibly important package. What do? Do you call the delivery company every 5 minutes and ask, "Is it here yet?" How about now? "Is it here now?" That sounds incredibly inefficient and annoying, right? You're wasting your time and you're tying up their phone line. In the world of software, this constant checking is called polling. This is where your application constantly makes requests to another server, asking for new data. Most of the time, the answer is no. Yet, every request still consumes massive resources: CPU, network bandwidth, and it eats up your API rate limits fast. This is especially painful when the operation you're waiting for takes a long time, like payments, deployments, background jobs, or third-party integrations. Polling technically works, but it's inefficient, slow, and wasteful. So, what's the smarter way? You can simply give the delivery company your address and phone number and say, "Please send me a notification when the package arrives." This is exactly what a webhook is. A webhook is an automated message sent from one app to another when a specific event happens. Instead of your app pulling data, the service pushes the data to your app in real time. To really understand this, let's compare it to standard REST APIs. REST API is pull-based. With a REST API, you're the one doing the checking. You ask server, "Did anything change?" A webhook, on the other hand, is push-based. The server notifies you the moment something changes. In technical terms, they are sometimes called reverse API or user-defined HTTP callbacks. But there is a technical twist here that confuses beginners. Usually, if you are the client, you just ask for data. But to use webhooks, the client must also act as a server. Why? Because to receive that incoming notification, you need to have a server running with a public URL that can accept incoming HTTP post requests. Interestingly, the URL you provide doesn't even have to be your server. You can provide a URL for a third-party tool like Zapier. You are essentially telling the provider, "When this event happens, don't tell me. Tell that guy over there." Setting up a webhook requires understanding 3 key components: events, webhook URL, and payload. Event is the trigger. It's the specific action occurring in the source app, like a successful payment on Stripe or a Git push on GitHub. The webhook URL is the address you register. It points to the server that will listen for the message. And payload is the actual letter inside the envelope. It's the data about the event, usually sent as a JSON. Now we walk through a full webhook cycle using a real-world example: a user buying a product on your site using Stripe. First step is registration. You log into your Stripe dashboard and find the webhook settings. You paste in your server's URL, let's say myshop/Stripe. Crucially, you also tell Stripe exactly which events you care about. For instance, payment succeeded or failed event. Next step is the event trigger. A customer is on your website. They enter their credit card details and hit Buy button. The payment is processed successfully. This action triggers the event inside Stripe's system. Third step is the post request. Stripe's server immediately creates an HTTP post request. It bundles up all the data about that sale into a JSON file, the amount, the currency, the customer ID, and fires it off to the URL you registered in step 1. Final step is the action. Your server receives that request at myshop/Stripe and reads the JSON payload, sees that the payment is successful. Then it updates your database to paid status and sends a confirmation email to the user. If you're building a webhook consumer, security is also a critical point. Your webhook URL is public. Anyone could try to send fake requests to it. And if you process them blindly, you could trigger false payments, duplicate orders, or unintended actions in your system. That's why you must verify that every incoming request truly comes from the provider you trust, typically by checking a signature or shared secret that proves the request hasn't been forged or tampered with. Webhooks are designed to be reliable, but they do not provide strict delivery guarantees such as ordering or exactly once delivery. Because of this, Webhook consumers must be built to handle certain delivery limitations. Webhook events are delivered asynchronously, so their arrival order cannot be relied on. You might receive an order updated webhook before the order created webhook. In these situations, timestamps can help you restore order of events. In addition to ordering, handling duplicate event is also important. To ensure delivery, providers may resend the same event more than once, leading to duplicate events. You don't want to process the same event twice. That's why idempotency is essential. This is a fancy word for handling duplicates. You should always check the specific event ID to make sure you haven't already processed that message. Now that we understand how webhooks work, let's look at where they're most commonly used. First, long-running or asynchronous tasks. Some operations take time, and you don't want to block your system waiting for them to finish. A common example is you upload a video for processing. Instead of checking, "Is it done yet?" the video service sends a webhook when processing is complete. Second use case is server-to-server data synchronization. When one system changes, another system needs to stay in sync automatically. For example, a payment provider confirms a payment, and your backend immediately updates the order status without polling the payment API every few seconds. And last one is third-party integrations. Webhooks are a natural fit when your application depends on external services. One example is a Git hosting platform sends a webhook when new code is pushed in, automatically triggering your CI/CD pipeline. Finally, it's important to remember that webhooks aren't a universal solution. They are not ideal in some situations, for instance when you need direct request response interaction, or you need strict ordering without extra logic, or in situations you need real-time bidirectional communication. For these cases, technologies like WebSockets are a better fit. To summarize, webhooks enable efficient, real-time, server-to-server communication. They eliminate constant polling and are perfect for long-running processes and data synchronization. If you understand webhooks, you understand one of the most important patterns in modern backend systems. Thanks for watching, and as always, see you in the next video.